tomorrow will be better. On the board here we have a system of two springs. The first spring is hung to a fixed point here as so, and then the second spring is attached to the end of the first spring as so, and then at the end of the second spring is hanging a mass which is 0.5 kilograms. Now here's the question: calculate the total extension of both springs and their combined spring constant. Follow me, dear friends. Solution. I'd like to start by recalling what this is all about. We are talking about Hooke's law here, according to which the force which causes a spring to extend is given by its spring constant times the extension in question. Okay, now in this particular case, what's going to happen is this: when we hang this mass at the bottom of the second spring, both springs are going to stretch by a certain length, okay? And that's what the question wants us to know. Now, to easily solve this, let us start by naming the extension of this first spring to be E1, and let the extension of the second spring be E2, okay? And we will make a statement here that the total extension ET is going to be the combination of E1 plus E2, all right? So how do we get E from here? This implies from this equation, E, the extension, will be the force divided by the spring constant. So this means if I take E1, for instance, for the first spring, I'm going to have that the extension of the first spring will be equal to the force divided by the spring constant of the first spring, all right? So let me start with the first spring, all right? This implies that E1 is going to be equal to, now, what is the force here over K1? I want to make an important notice here, guys. Looking at this system, the only force which is susceptible to causing these springs to stretch is the weight of this mass here, all right? And we know weight is given by m times g, where g is a gravitational acceleration, all right? So here I'm going to have that this is going to be equal to the mass here times gravitational acceleration divided by the spring constant of the first spring. So this is going to be nothing else but 0.5 kilograms times 10 meters per second square divided by K1, which is 100, all right? 100. And this gives me nothing else but 5 divided, okay, 0.05 meters difference, because extension is in meters. Okay, let me divide the board like this. Now the next thing we have to do now is to find E2 in the same way, all right? So I'm going to say here that E2 is going to be equal to F all over K2. Now why is it still the same F and not F2 nor F1? This is because if you look at this, there is no other mass which is capable of causing this spring to stretch. The only mass which is going to cause either of these springs to stretch is this. Of course, we have to make a reasonable assumption here, dear friends. It is the fact that we will neglect the mass or the weight of the second spring, all right? We will have to neglect the mass and the weight of the second spring. Otherwise, if we don't take this assumption, we will have to consider the mass of this, as the mass of this will also influence the extension of the first spring, all right? So this is a reasonable assumption to make. The mass of the second spring is negligible, all right? So that is why the only mass which will cause an extension, be it in the second spring or in the first spring, remains the weight of this mass here, okay? So that is why we have F and F, and not F1 nor F2, because it's the same force which will cause the two springs to stretch, all right? So again, we're going to have here that 0.5 kilograms times the acceleration due to gravity all over K2, which in this case now is 50, and this will give you nothing else but we will have 5 divided, all right, this is 0.1 meters. Therefore, the total extension for both springs, as we said, was E1 plus E2 is going to give us 0.05 plus 0.1, which is equal to 0.15 meters. So this is the total extension of both springs. Be careful, both springs are going to extend by different lengths. Why? Because they both have different spring constants. Very good. Now they are asking also for us to find a combined spring constant. So now we would consider that all of these two springs were like one spring on which is acted a mass of 0.5 kilograms, producing an extension of 0.15. So we have the extension here, which is 0.15 meter, and then we have the force, which is 5 Newton. Where is this 5 Newton from? 0.5 kilograms times 10 acceleration due to gravity gives us it. So we are to find now K. Therefore, K, according to this formula here, K will be F divided by E, F divided by E here, which is going to be equal to F5 divided by E 0.15. I leave you to give me the final answer of this in Newton per meter in comments, because tomorrow will certainly be better.